Then the next question is question number 10. Question number 10. It says this. Let A be a 2 by 2 matrix with trace of A equal to 6 and the determinant of A equal to 5. Find the eigenvalues of A. Okay, for this equation, we have a 2 by 2 matrix. Suppose we have a matrix A. We have a matrix A and it is a 2 by 2 matrix. It means that it has 2 rows and 2 columns. It is of the form A, B, C, D, like this. What is a trace of a matrix? What is a trace of a matrix? A trace of a matrix is the sum of the elements on the diagonal. Sum of elements on the diagonal. So it means that the trace of A is equal to A plus D. And in the question they says that the trace is equal to 6. And what is the determinant? What is the determinant of a square matrix? Determinant of A in this case. This is this determinant A, B, C, D. This determinant is equal to A, D minus BC. Is it true? Yes? Yeah. And we have the determinant which is equal to 5 in our question. And they ask us to compute the eigenvalues. How do we compute the eigenvalues? Eigenvalues are computed by solving what we call a characteristic equation of a matrix. What is a characteristic equation? We need a characteristic equation. What is the characteristic equation of A? Characteristic equation of A. It is a equation of this form. Determinant of a matrix A minus lambda times I. This is a identity matrix equal to 0, where lambda is eigen. This is eigenvalues. Lambdas are eigenvalues, and then this is the characteristic equation. Normally, when we find these eigenvalues, we solve this kind of equation. So for this matrix A, for the matrix A, we have matrix A, we have to compute the determinant of matrix A, which is equal to A, B, and C, and D. This is A, and minus lambda times the identity matrix. And the identity matrix is 1, 0, 0, 1. Like this, and we need this determinant. So how do we compute this determinant? Anyway, ibintu byose ndimo gukora ntago byari ngombwa kugira ngo ubishyire hari mu gisubizo, gusa ndabikora kugira ngo ubone neza uburyo iki kibazo kimeze gutya gisubizwa ubyumve neza. So then this determinant is equal to this is we first compute this difference of these matrices. So we have A minus lambda. Yes, is it A minus lambda? Yeah. Yes, we have A minus lambda, and B minus 0, that's B, and C minus 0, that's C, and then D minus lambda. So we have to compute this determinant, and this determinant, if you can see where it's equal to A minus lambda and times D minus lambda and minus B, C. Yes. And if And if we expand this product, we will get this one equal to AD. This is AD and minus A lambda and minus D lambda and minus B C. And this is equal to AD, yes, minus BC. What is this? What is this? We have AD minus BC and minus lambda. We have lambda here and lambda here. We can put it in evidence. Then lambda times A plus D. Like this. And what is this now? If you look above, what is AD minus BC? AD minus BC is this determinant. Yes. So then our equation, characteristic equation becomes, there is one term which is missing. We have also minus lambda times minus lambda. Here there is one term which is missing, which is lambda squared. Then plus lambda squared here. Yes. So AD minus BC, it's this, that's 5, which is the determinant of A. So this is equal to determinant A, right? Yes, determinant of A. And then minus lambda, and lambda plus times A plus D. What is A plus D? Do you remember A plus D up here? This one, A plus D was the trace. This was the trace of A. So then A plus D is lambda then times the trace of A, and plus lambda squared. Yes, that's the characteristic equation. So we have, let me write it here. We have our characteristic equation. I start with lambda squared. Then it's lambda squared and minus lambda times trace of A, yes, and plus determinant of A. That's the characteristic equation, which is equal to, this is determinant of A equal to 0. And then we have to replace this trace by its value and determinant by its value. Normally, what we needed was only this one. Biriya byose nakoze hejuru ku ntago byari ngombwa, ntabyo bari batubajije. Ubundi cyo bari bakeneye kumenya no kumenya kuko iyo ufite a square matrix, this relation hold. Lambda squared minus lambda times trace of A plus determinant of A equal to 0. And you have to solve this equation, and then you get your eigenvalues, and yes, eigenvalues. And if you are asked also eigenvectors, you can compute them. So then let's go ahead and compute our eigenvalues. We have lambda squared minus trace of A is equal to, they have said that it's 6, then minus 6 lambda, and then plus determinant of A, and they said that the determinant of A is equal to 5, then equal to 0. And we solve this equation, and when I'm solving this kind of equation, I told you, for those who watched my previous video, when we have 1 here, so we find the two numbers whose sum is minus 6 and whose product is 5. So those numbers are minus 1 and minus 5. So we have lambda minus 1 times lambda minus 5 equals 0. Yes. And we have lambda equals to, then we have lambda equal to 1 or lambda equal to 5. And those are eigenvalues. Therefore, our eigenvalues are values are 1 and 5. That was it. Yes, 1 and 5. And umunyeshuri nyine wakurikiye neza ntabwo biriya byo hejuru yari bikeneye igisubizo cyari kuva hano gutya kugera hano. It was only this one. The answer was this. Biriya byo hejuru nanyuzemo byose ntabwo bari babikeneye, nabinyuzemo gusa kugira ngo mwereke uko impamvu yabyo. Ndakeka kandi ntacyo byishe, kandi mubikunze munono mubashe gusobanukirwa n'impamvu biba bimeze kuriya. Good. So let's move on.